Hello, today we'll be going over SLO1, which is identifying the major classes of lipid proteins and explaining their importance in transporting cholesterol, triglyceride, and other lipids throughout the body. So when it comes to lipoproteins, there's spherical macromolecule complexes that act as transport vehicles for hydrophobic lipids in plasma. Because lipids are like triglycerides and cholesterols, which are not water soluble, they need these specialized particles to move efficiently through the bloodstream. At the center or at the core, we can find nonpolar molecules such as triglyceride and cholesterol esters. Surrounding the core is a single layer of phospholipids, free cholesterol, and specific protein called alloprotein, which stabilize the particles and allow it to interact with cells and enzymes. Together, this structure enables the solubilization and the target delivery of the lipids to tissues that need them for energy production, membrane synthesis, or even storage. So when it comes to lipoproteins, it's important to understand that there are 5 major classes, each differing in size, density, and even lipid composition, which determine their specific roles in lipid transport. First, we're going over chylomicrons, which are the largest and least dense particles. They carry dietary triglycerides and cholesterol absorbed from the intestine to the peripheral tissues, primarily for energy storage or even immediate use. Next, there is the very low density lipoproteins, which are VLDL, which are produced by the liver to export triglycerides synthesized from excess carbohydrates and fats to tissues throughout the body. As VLDL particles are metabolized, they lose triglycerides and become intermediate density lipoproteins, or IDL, which are transitional particles that can either return to the liver or be further converted into low density lipoproteins, or LDL. LDL serve as the main carrier of cholesterol to peripheral cells, where they're used for membrane synthesis and steroid hormone production. However, elevated LDL levels contribute to which is known as bad cholesterol. Finally, there's high-density lipoproteins, or HDL, which perform the reverse function. They scavenge excess cholesterol from tissues and deliver it back to the liver. HDL is protective and is often referred as good cholesterol. Together, these classes form a dynamic system within our bodies. Now we're going to talk about how structure determines lipoprotein function. The structure of lipoprotein directly determines their function in lipid transport. First, density is inversely related to the lipid content. The more triglyceride or cholesterol ester a particle carries, the lower the density. This explains why chylomicrons, which are rich in triglycerides, are the least dense, while HDL, which is higher protein content, is most dense. Next, apolipoproteins play a vital structure and regulatory role. They stabilize the lipid protein particle, preventing lipid aggregation in plasma, and serve as molecular tags that guide the lipoprotein's interactions with cellular receptors and enzymes. Finally, lipoproteins are not only static, they undergo dynamic remodeling. Lipases and lipid transfer proteins continuously exchange lipids and apolipoproteins among particles, adapting their compositions to the body's metabolic needs. The remodeling maintains lipid balance between the tissues and support proper energy exchange and cholesterol homeostasis. Okay, now we're going to focus on the physiological importance of lipoproteins. Lipoproteins play essential roles. They extend well beyond simple lipid transport. First, they facilitate the absorption, the movement, and the target delivery of lipids required for energy production and the membrane synthesis. Without these complexes, hydrophobic molecules like triglycerides and cholesterols cannot effectively reach tissues that depend on them. Second, lipoproteins maintain cholesterol homeostasis between the tissue and the liver. This balance ensures that the cholesterol is available for vital processes such as steroid hormone or bile acid synthesis, while preventing excess accumulation in peripheral cells. Finally, maintaining a proper balance between LDL and HDL is critical for cardiovascular health. Elevated LDL promotes plaque formation, whereas HDL helps clear cholesterol and exert antioxidant and anti-inflammatory effects that protect the vascular integrity within us. For the question, it goes, Abby, a 30-year-old healthy woman, fasts overnight before her yearly blood test. Her laboratory results show increased levels of high-density lipoproteins, HDL. Which of the following shows the primary function of HDL? A. Carry cholesterol from peripheral tissue back to the liver. B. Transport triglycerides from the liver to adipose tissue. C. Serve as storage form of triglycerides in adipose tissue. Or D. Serve alongside cholesterol for memory synthesis. I'll give you 5 seconds. Perfect. If you chose A, you are correct. Remember that HDL is the reverse cholesterol transport, collecting excess cholesterol from peripheral tissues and returning it to the liver. This function helps maintain the cholesterol balance and provides prevention. Okay? Thank you so much for listening and have a great day. Bye-bye.